Okay, so let's talk about ownership in Rust. This is arguably the most confusing topic as long as the Rust language is concerned, and probably the reason why many people hate the language. And the fact is this: when you create variables, when you're writing programs in any language and then you keep on creating variables, every single value you store in a variable takes up memory, and those memory are being occupied and monitored. Okay, and you can only have as many memory as the system provides you. So what happens is that until Rust, some other languages have devised a means to clear up unused variables. Okay, let's say you are inside a function and then you create some variables. When you leave that function, those variables, the values will still be occupying some memory. So what some languages does is they give the programmer the ability to remove those details from the memory so that the memory can be used for something else. But it's very, very not effective at all. In fact, in C language, that is how it is done, and that leads to a lot of errors, memory leaking, and so on. Some other languages like JavaScript, Java, and all that use what is called garbage collection. So where they say the system will continue to look for these variables that are no longer used and then clear the memory so that they can be reused later on. But the problem with this is that whenever it is time to clear the memory and the code is running at runtime, the system will take up a lot of resources while trying to do that. And so what that causes is that if there are visitors visiting your site and then your server is trying to serve them, you end up with a server that is very, very slow, and it does this periodically. So but Rust, on the other hand, came with something else. It introduced a different scenario altogether, where it says instead of using a garbage collection, or instead of leaving the garbage collection to be done by the programmers, let's do it in this way. Whenever a variable goes out of scope, it is dropped. Okay, so if you are in a function and you create a variable and then you are using that variable, at the end of that function use, the variable is dropped, which means the memory is no longer valid. It can be reused for something else, and this is very, very effective. This is the most important reason why Rust is very, very effective for a lot of things, and is being used for memory performant scenarios. And I'm going to show you exactly how this works in this case. Let's say you have a variable inside this main function and you called it A, and then it's a string slice, and then you store something like hello to it. Okay, what should happen when this function ends? So what Rust does is, at the end of this, it does that automatically. At the end of this function, it will call a function called drop. Okay, you're not going to do this yourself, it will do this, and what happens is that this memory is no longer being used at this point, and then it can be reused for other things, you know. And this is very, very effective, and it works really well. At the end of the day, Rust achieves effectiveness and durability using this method. Now, but this can be very confusing. You know, in other languages, when you have a variable, you can reuse it however you want, and then you don't need to care about anything because the garbage collector will take care of that. But let me make it very clear for you. Okay, let's start by creating a different function that we'll call let's just call it greetings. Okay, and then this function, let's say it will return a string slice, or let's just have it return just a string, an integer, let's say i32 value. Okay, now in here you created a variable, let's say you call it 34, and you return this value at the end. Now whoever uses this, calls this function, let's say inside here you create another function that you call greet, and then you call this function. Okay, and whatever is returned is assigned into this variable. Now watch what happens here. At this point, when you created this variable comes into scope. Okay, and 43 is bound to this variable. Now at the end of the day, when you return this value, the ownership for this is assigned back to this variable. Okay, and let me make it a lot easier for you. If you have a variable that you called A, and then you stored 43 inside it. Now if you create another variable that you called b and you try to assign a into it, now we've moved the value of a into b. Now what happened here exactly is that the value 43 that was inside a is now copied into b, and the reason is simply because this variable at compile time, the size will be known. It's just an i32 variable. However, if we were using a value that at compile time its memory size will not be known, like a string, let's say this is a string, let's say you have this string, right? Let's say you have this string, and then you create another variable and you want to reuse what we have in here, and you decide to move what you have in here over here. So you're moving the content of hello to word. At this point, after this declaration, hello is no longer valid. In fact, if you try to use this hello variable, it's not gonna work. Now watch what happens. Rust has started warning us already. It says borrow of move value. So we've already moved this value, okay, inside word, but they are trying to use it again, which simply means once you move a value from one variable to another, you can no longer use that variable because it's now invalid. And Rust does this specifically to prevent what is called data racing. So what Rust does to limit this is this: once you have a variable, especially of type string, and you move it to another variable, it is called move. Okay, the value has been moved to here. While if it is a variable of type that its size is known at compile time, it will just copy it from here. The only thing it will do is in the stack, it will copy the value in the stack, and you know, accessing value from the stack is very easy and very fast compared to that of the heap. And that is why Rust has to invalidate this first variable and then use only this one. So this one is no longer valid at this point. Its memory can then be reused for something else. Now this is where confusion comes in. So does it mean that I will have to, if I want to use the value in here after moving it to this one, okay, let's say I have another variable called c, and then I want to use what is inside hello. You can't do that, okay? So in order to work around this, what you can do is to take a reference of that value, okay? However, you can't take a reference of a value when you've already moved it. So you can do that over here, or for the word, you also take a reference of it. So now this word variable and then this c variable are all having a reference to the hello, okay? They did not acquire ownership of this hello, so this variable is still valid at this point because those other variables that are using it by reference. It's like when you take a picture. Let's say you have a car and you want to borrow it to your friend, and then you can say, okay, I can take a picture of this car, and then you can use that picture and post to your friends that you now have a car. You can do that for thousands of people. When they come, you take a picture of the car and you give it to them. Now they are borrowing that car by reference because they're just taking pictures of it. You still have the ownership of that car at that point. So that is what referencing does. If you use this and symbol, okay, and then the value, the variable, you are now taking a reference of it, just like a picture of it. You can do whatever you want with it, but you can't change it. However, borrowing, in this case, where you now assume the owner of that variable, then when someone comes to take a picture of the car will no longer be there. So then they can no longer have a reference of that car at that point because you've already borrowed it to someone, okay, not by reference, because the person you borrowed it to took just a reference of it like a picture. Then you can also borrow it to other people by references, which is just a picture. But if you give it to them and they leave with the car, You can no longer take a picture of that car. So that is simply how it works, and this is very, very important, and it also makes a lot of sense because this is how things work in the real world. If you borrow something to someone and they live with it, you no longer have it at that point, so you can no longer borrow it to someone else. However, if you just borrow the reference to that person, like a picture reference or whatever, then you can reuse it. You can borrow it to someone else as a reference too, just by taking pictures of it and borrow it to them. So this is exactly how Rust takes care of it. If you want to reuse a variable, just take a reference of it. But if you borrow it to someone, not by reference, but totally, you gave it to the person, now this variable now has the total ownership of this value, and so you can no longer borrow it to someone either by reference or by borrowing it to them directly.